Greetings, Dr. Will here. Thank you for tuning in to listen to the serialization of my best-selling book, What You Don't Know: Successfully Lead a Software Project Without Tech Expertise. You can always cut to the chase and purchase the book in your preferred format. See the show notes for the link. Let's get started. Episode 1, Preface, and Part 1 of the Introduction.
In the last year, I started helping a few SaaS, software as a service founders, who have hit some roadblocks while developing their products. One, a medical charting application, was seeing an increase in the number of issues reported by their customers and a lack of progress in the development of new features. Like many SaaS founders, their backgrounds were in the problem domain and marketing. They saw a need for the product and jumped in. They got to work pre-selling early adopters and hired contractors to do the development after they had validated the demand. Pre-selling the system to early adopters validates the idea and generates much-needed cash flow for building the system. They built the system, grew to around 100 customers, and then experienced a bit of tech churn. The original developers moved on to other things and were replaced by other developers. Eventually, that group shrunk down to a single part-time developer. So with almost no tech support, a growing list of issues, complaints, and feature requests from their existing customers, a need to meet HIPAA requirements, and more questions than answers, they reached out for some help. I happened to be in their founders group online, and hearing of their problem, I offered to lend a hand. I discovered that their developers had built a moderately well-functioning system as an MVP. The system was not completely unsupportable, but seemed to be a very difficult system to support. A few significant trouble spots stood out. First, there was no documentation. None. Of any kind. Second, the founders not only had limited knowledge of where the system was deployed, but also no information about how or where to find the necessary login credentials to maintain the system or to have it maintained if the one remaining developer went missing. Third, the entire project was being managed on Trello. Now, Trello is a fine system, but it's not built for doing everything from requirements capture management to testing management to customer support to, well, you name it, everything. As an example of the troubles, to fix a problem reported by one customer that the developer could not reproduce, an extremely slow response time on one screen, the developer modified some code. Because the original problem was not reproducible, the developer skipped deploying the fix to the available staging system and deployed it directly to the shared production environment, without passing through any test. The phones lit up, so to speak, as multiple customers reported a new problem with the deployed fixed software. The change was reverted to the status quo ante, and things have proceeded pretty much as they had before they deployed the fix. So the founders were sitting on a relatively stable MVP, but one with a collection of known issues, problems, and pent-up demand for new features. The system was stable but fragile. Support was thin, and the development process was completely ad hoc. I started by bringing them up to speed on what they were doing, building a software system, which is a different activity from almost anything else you might think to do. I helped them understand the importance of some seemingly insignificant things, like written documentation, some of which they had already discovered. I also translated a lot of technical geek-speak jargon into natural language. Most important, however, has been not only helping them understand why things are the way they are, complicated, but also the demystification of the software development process. Complexity doesn't need to be a mystery. Chess is a complex game, but one of perfect information. Software development should be more like that. All the while, I wondered how many other folks have leapt into building software having been seduced by the apparent ease of coding. I mean, how hard is it to type anyway? Introduction. Let's start with what is software. It is the set of instructions that, when executed on a computer, provides desired function and performance. Of course, you have to define the desired function and performance. How that's defined and where it is defined and documented are important follow-on questions in software development. The definition of the desired function and performance may include many written documents. One of the first unfamiliar words I used with my friends was documentation. It's the entire body of written documents used to support the development and ongoing sustainment of a software system. Actually, any system, but I digress. Software has some characteristics that make it rather unique. First, it is developed, engineered, rather than manufactured. Second, it doesn't wear out. Instead, it eventually becomes obsolete. Third, in a world of mass production, software is often custom built. It may be assembled from existing components, but it's just as likely to be written entirely from scratch. We increasingly use existing frameworks, components, and tools that facilitate developing software from existing parts. We customize those existing parts, components, and connect them. Assuming each part is fit for use, this reduces the time spent on development unless the part doesn't actually quite do exactly the job required. If that happens, then you get to decide whether to make the part fit or replace it with a different, perhaps handmade part. Software is complicated. It is complex in a way that's very different from the way hardware is complex. Hardware is complex because it has many billions of parts. Many of them are exactly the same. In hardware, it's the sheer number of parts that boggles the mind. Software is complex not because there are so many billions of parts, but because no two parts are the same, or no two parts should be the same. If two parts are the same, then we have a different problem. Generally, if a developer needs the same code in more than one place, they will write it once and then refer to that single copy from both places. Finding the same code written twice in two different places is considered a programming error. Software, when it executes, has an incredibly large number of states. A state is a particular configuration of the data and code at any moment in time. There are more software states possible than there are physical hardware components in the system, and remember, there are billions of those. So software is complicated, and because of that, its construction is also complicated. Both the software and its construction are difficult to manage owing to their mutual complexity. Software is conformable. Software conforms to its environment. The environment of a software system includes the hardware, other software, for example, the operating system, and the people and/or institutions supported by the software solution. Software is not ever used by itself. It's always part of a larger system. The environment is never static, unchanging. To continue to provide overall system conformity to all of the external requirements imposed on the system, the software is usually the leverage point for the updates because software is changeable. Software is easily changed. Of course, easily is a relative term. Changing hardware is not only an engineering process, but also a physical, manufacturing, and logistical process. Replacing hardware with a new part requires engineering to re-engineer the part, manufacturing to build the part, logistics to move the part physically, and maintenance to remove the old part and replace it with the new part at every location. On the other hand, changing software is only an engineering process, with all the rest of the steps done automatically across all systems simultaneously. When software is developed as part of a larger system, it's usually the last thing completed on the system. So that usually allows the system developers to add functionality, performance, and different additional types of behaviors to the system by changing only the software. This creates an ever-moving target of what the software is supposed to do, making an already complicated process even more so. When you add that new behavior to the system late in the process, you'll probably cause the schedule to slip on the larger system's development. Software APIs, application program interfaces, make it possible to easily interface with new platforms. The formal definition of APIs helps to build larger, more complicated, and more capable systems by increasing the number of other systems that are connected. This also increases the complexity and the difficulty of managing it all. Software is invisible. Software without hardware is an abstraction, a mathematical abstraction to be precise. Computer hardware without software, on the other hand, is a boat anchor. Useful hardware machines can be built that have no software, but no software is useful without a hardware machine to execute its instructions. The code is a natural language-like representation of the instructions that, when translated into ones and zeros, becomes the actual instructions for the computer. Sure, you can look at the ones and zeros if you like, but you might as well stare at a blank page. The code can be read, but the code is not exactly the executing instructions. Complex, conformable, changeable, and invisible. It is like sketching a millennial chameleon ghost crossing a desert in a windstorm.
That ends the preface and part 1 of the introduction. Join us next time for episode 2, part 2 of the introduction. That's it for me for you for now. Be careful out there. Bye.